Hello student, now we'll see RC phase shift oscillator. RC phase shift oscillator using op-amp. We know to get a sustainable oscillation we have to follow Barkson criteria. The Barkson criteria first state the phase shift between the input and output should be 180 degrees. That means an oscillator will operate that frequency for which total phase shift introduced as measured from input terminal through amplifier and feedback network and back again to input is precisely equal to 0 degree or 360 degree. That means you're inverting if your amplifier is having phase shift of 180 degree, there should be 180 degree phase shift for feedback network. If your amplifier introduce 0 degree phase shift, that means your feedback network should follow 0 degree phase shift. The second statement states that the magnitude of product of open loop gain of amplifier and the feedback factor beta is equal to or greater than unity. This product A beta is called as loop gain. This is RC phase shift network. Each RC ladder introduce 60 degree phase shift. This RC phase shifts oscillators is having three identical RC phase shift network which is cascade to each other. Each RC network is designed in a such a way that will introduce 60 degree phase shift. So this first will introduce 60 degree, this second will introduce 60 degree, this third will introduce 60 degree. So total phase shift will get 180 degree. So this is RC phase shift oscillator using op-amp. We know the basic block of any oscillator is amplifier network and feedback network. This feedback network is also called tank network. This tank network is classified into RC or LC. If the tank network is having resistor and capacitor combination, then it is called as a RC oscillator. If it is the combination is with LC, inductor and capacitor, then it is called as a LC tank circuit. Here is RC phase shift oscillator because the tank circuit is of resistor and capacitor combination. This is feedback network and this one is amplifier network. Here input is given to inverting terminal. So we know the output will be 180 degree phase shift of input. We know there is a relation between the output and the input voltages of 180 degree. So 180 degree phase shift will introduce through this amplifier and the remaining 180 degree phase shift will given to this tank circuit or feedback network. The output of this amplifier is applied to the input of this RC phase shift network. This level of attenuation is decided by beta or the feedback factor, and the open loop gain of this amplifier is equal to A. The gain of inverting amplifier is decided by this RF and RI resistor. Gain is adjusted in such a way that the product of A into beta is slightly greater than 1. In RC phase shift oscillator, the beta is equal to 1 by 29. So we have to keep the gain of amplifier is greater than or equal to 29. So you'll get RF upon R1 is greater than or equal to 29. So it say that your RF is equal to 29 times of R1. This values of RF and R1 will ensure sustained oscillation. We know for the sustained oscillation we have to keep product of open loop gain and the feedback gain should be greater than or equal to unity. This is the frequency of oscillation which is equal to 1 upon 2 pi root 6 RC. This frequency of oscillation of RC phase shift oscillator is depends on this component of feedback network. Generally, this RC phase shift oscillator is used over the frequency range of 100 Hz to 100 kHz. So this RC phase shift oscillator is mainly used in communication application. Thank you, student.